Well, we took the caps off, or the front cap off, and the shaft looks really nice and shiny. I was a bit concerned because the bolts were not really tight, but the shims, got a light problem here, the shims are there, the bearing shells look good. I'm just not sure if that's all correct. Need to look that up on the drawings if there is everything in it which is supposed to be, but yeah, the shaft looks great. Welcome back. So here we have the whole drama. That's the bottom side of the very rear one, and it was hot. And that's the front side of the rear one. Got the same grind mark as the other one. This is the very bottom front one, looks good. And this is the rear front one, which looks okay, sort of. It's got some burrs here. But certainly they are shop made. They got a number as well. Let me check that number. They got a number as well. It's GS6531S. GS6531S. I think this is a engine bearing as well, because I found out the small ones are actually conrod bearing for a farm oil tractor. That's the only reference I found to that number. I'm gonna check for the other ones. Essentially in the long term I think we're gonna replace all of them. I need to educate myself what we're gonna use for that, but that's certainly not original. I can feel a little bit of a ridge here, so it's been running with these bearings for quite a while, because you can feel it worked into the surface here. Just a little bit. The surface itself is smooth, there's nothing on it. There's a little bit of grime here, don't know what that is. No, it's soft, it's not metal. So all we're gonna do is check the shaft if there is anything, but I don't think so. We certainly could reuse the front bearings for now, which we will do. We also will scrape the rear ones a little bit to get rid of those ridges and put it back together. What I also will do, I put the bearing caps back on and take some measurements, and then if you don't run it too fast, keep it well oiled, we should be okay for a while. But it needs addressing, clearly. The top one looks a bit worse. There was plenty of oil in the bearing housing. I think it was running with low oil for a while, at least. I tried to find out a little bit more about the history, what actually happened to the machine and how it actually ended up there when I bought it. There's one thing here, that pulley looks a bit chewed up, I don't know why. I think it was a slipping belt. I was first thinking about taking the whole thing apart, but to be honest I don't really want to, because we're going to take it apart again. So let's take some measurements, precise measurements of the shafts, and also the bearing housings when they're fitted without the shims, and then try to find some bearings. I already got some sources for the bearings. Hopefully they have something which fits. we'll see. That's why we're going to take some measurements now. So we took some measurements, verified it with a caliper, and we can confirm the shaft is round and it's the same diameter at any place except in the middle where that little ridge is. So that's 66.62 millimeters here and 44.33 millimeters here, all the way up and down. So I'm quite happy with the shaft so far. I measured it a couple of times and you can feel the micrometer is the same force at any place. So we know our shaft is good, which is at least a little bit of a relief. The truss bearing looks good as well. It's actually a ball bearing. As far as I understand, that was a later addition. The older machines didn't have that ball bearing, it was just a washer or so. To get it out, you're going to loosen, hopefully that's visible, there's some light on here, repaired the flashlight by the way. Loosen that bolt here and screw that back. That releases the tension of the truss bearing, so you can take the shaft out easily. Okay, so now we need to measure the inner diameter of the bearing housings without the shells, and then we measure the thickness of the shells. I did a few brief checks and they are not very equal, let's say this way. So we'll see what we find. I had to use a new caliper. I'm not really happy with that one here. It's not worn in. I smashed the glass on the other one, I need to fix that. Alright, let's get over to the bearings. We just used some snap gauges for that, and I'll do that quickly off camera and come back with the measurements. So we spent a bit of time measuring here. We got 47.6 vertical and 47 horizontal, and here we got 69.83 vertical and 70.2 horizontal. So this is what the shims are taking off. Interestingly, on the rear there were two shims. There were 1.28 to 1.36 millimeters in total, the brush shims, and on the rear there was just one, which is 0.8 millimeter roughly. At the front it was steel, looks like steel. They are not very even here. If I check those, yeah, that's 0.64. And that's 0.66. There's some dents and a bit of rust. I think they're shop made because the holes are not round. Assuming the shell is the same thickness, we'll check that in a minute. The caps are roughly 0.2 millimeters too high, both of them, for whatever reason. Here we got a thread micrometer here, which is a nice piece of kit actually. I just checked it, it's on 0 because we got a round surface. So what we're gonna do is just checking the thickness of the shells here. It's got, I don't know if that's visible, it's got a point here. Light. We have a point here and a sort of anvil on the other side, so we can go on the round surface, and that gives us roughly, what's that, 2.05 millimeters. Let's double check that with the caliper. I like to check them with the caliper just to make sure I'm not reading garbage. That's 1.8, 1.9. Maybe I was on the groove here. 1.85. I'm measuring 2.05, very constant actually. I'm measuring 2.07. It's interesting, I'm getting very constant results here. That's 2.04. Okay, let me check those shells. Well, the whole thing starts making sense. I have a strong feeling that these with the cross cut where the bottom ones make sense, because this is the hole where the wick sits. But at some point someone had the bright idea to put those at the bottom. So, because they are not worn and these are worn. So I don't know if that makes sense. Surprisingly, these really bad looking ones, they got the same thickness. I measured 1.83 millimeters plus minus 0.01 millimeter. So they look bad and I can feel that ridge, but in general they're good. So it's just the front ones which we need to look what's going on there. Again, the rear one was shimmed a bit odd. I need to do the maths with all the thickness of the shells and what I measured on the shaft, if that makes sense. Maybe we're just a bit tight, I don't know. The front ones certainly have an issue, but it makes sense. If the machine sits there, it fills that groove with oil, and then you can turn it easily. Because there is enough gap to get the oil through from the oiler. I need to think about that. But I think this was a botched repair attempt. Who knows? Anyway, as usual, the job gets bigger than expected. We need to sort that somehow. We'll come back with some ideas. So, and that's the whole thing looks without spindle and just the bearing caps on top of it. The shims go in between, so that lifts the caps to the right dimension, and we're still working on ideas here. It certainly needs a clean as well. And that's how it looks with the original top shells at the bottom. We can see that hole perfectly lines up. I think that confirms my theory that these shells were at the bottom. And I think at the rear it's the same, because there's the same hole with that oil wick. So we scraped the high spots away here as well, and now we give it a good oil, put it back together until we wait for the new bearings. So we cleaned and scraped the top ones as well. Just taking some measurements for reference. The rear ones are 28.7 wide, both. The front ones are 36.6, the inner one, and 42.5, the outer one. What I did, I just scraped the high spots away with one of these. You just scrape lightly across the high spots. You can see there was another one here, and no pressure, just go over it. So we cleaned that oil hole. There was a lot of gunk in that oil hole. Might be that was one of the reasons. So they still look a bit done, but they are smooth. It's that, I think that's oxide here. So yeah, we just put it back together with all the shims and see what it does. We'll leave the rear one a bit loose. Not entirely sure with those shims here. We'll see. There was a mark here on one of those, so it was binding on the shell. We'll see. Just put it back together and see what it does. So we got it all back together. At the moment we're just running in. See how much clearance we got. I'm running a relatively thin oil at the moment. So leave that running for a while, check the temperature, and then we check the clay. So we gave the oiler a clean. To test them it's quite simple. Just open them and check if they drip. And it drips, so probably a bit much, but it's okay for now. And there is a side glass here, you can see the dripping, and if the oil comes up in the side glass you got too much. So pretty simple concept, but it works. So we got everything back together, and it runs fairly smooth. It's got about 200 play on the spindle. It's a bit stiff, but we just run it for a while until the bearings, everything's seated. Checks the temperature, and if it doesn't get hot, I think it's alright. So that should conclude the spindle bearings for now. We're certainly going to replace them at some point, but I feel quite confident at the moment. It's at least usable. So we finally found a holder on the carbide insert, and it does really well. There's some rust on the shaft, that's the reason why. So this stuff is pretty hard, so it's doing great. Nice chips. And we'll see how it looks like. Look at these chips here. They're really springy and pretty long. So this is about 2 meters long here, and it's really springy. Yeah, it's doing well. Happy with that. And that's how the surface finish looks like. Nice and shiny. There is still a bit of a cut in the shaft. I'm going to turn that down a little bit more, because otherwise we can't use it. It doesn't shatter, it appears to be round, so the bearings don't get hot. So I think we can use it for now. Thanks for watching, thanks for subscribing, until next time.